Okay, sorry. Which one? Am I 29. Nine minus 9b to the fourth. It's number 29. Looks very unassuming, right? Just two terms, nothing major happening. Well, we do have some stuff that's going to happen that's going to be kind of weird. GCF, 9. Okay, so this is equal to 9. When I factor out 9, I need enough room for two terms. What's still there? 1 minus b to the fourth, right? Now, 1 minus b to the fourth. Two terms, right? Does it look like difference of squares, sum of squares, difference of cubes, sum of cubes? Well, we've seen this before, right? When you have b to the fourth, you can always look at b to the fourth as b squared squared. So I'm going to have to maybe take a look at this on the side. 1 minus b to the fourth. Can I look at that as something squared minus something squared? So how do I get 1? I square what? 1. How do I get b to the fourth? I square b squared. So a in the problem here is 1, and b in the problem, so to speak, using the formula, the b in the formula is actually b squared here for me. Now, what is the difference of squares formula? So, yeah, this turns into a plus b times a minus b. Right? That's what my formula says. For us here, a is 1 and b is b squared. So coming back up here to the problem, I have equals, here's my 9, and then that's going to turn into two things, right? This right here is two things. It's what? 1 plus b squared, and then 1 minus b squared. Now 1 plus b squared looks like two terms, but it's a plus, right? And it's squares, b squared, and it's 1, 1 is 1 squared. The formula for sum of squares is that it's prime. In other words, there is no formula, so I cannot break that down. The second one, though, is another difference of squares. You see that? So 1 minus b squared, if I do that over here again, I'll do it in green. 1 minus b squared, that's the same as 1 squared minus b squared. So the formula for that will be what? 1 plus b, 1 minus b. Does everyone see how this is another difference of squares here? A is 1, B is B. So, if we're using the formula, that's what's happening there. Just plug it in. And now these two terms are not difference of squares or sum of cubes or anything like that. So we are prime on all these, so we are completely factored. Box it up. I will entertain one more if there is another question. 40, did you say 47? 27. All right, 27 it is. 4x cubed plus 10x squared plus 6x. First thing is what? GCF, right? There's a 2 goes into all those, and there's an x in all of those. So 2x can be factored out. Enough space for 3 terms. What do we have? 2x squared plus 5x plus 3. Are we good up to that point, sir? Yes? Okay, now AC method. I'm doing that because what's in the parentheses has 3 terms. 3 terms always says AC method. So we take the 2 in front, multiply times the 3 in back. That gives me a 6. I have a 5 down on the bottom. And now I have to come up with two numbers that multiply to be 6, add up to be 5. 2 and 3, right? How about 5 and 1? No. 5 and 1. I mean, not 5 and 1. 6 and 1 is what I meant to say. How about 6 and 1? No, because it's got to add up to be a positive 5, right? 6 and negative 1? I could do that, but then they wouldn't multiply to be positive 6, right? There's only one way it should go, right? There's only one. So, what did you say it was, 2 and 3? Now, I think we said we were going to do the grouping way, right? A lot of us were going to do grouping. That's where we took the two outer terms and we rewrote the inside. Is that what we wanted? Okay, that's how I'm going to do it too. So I take my 2x, here's my parentheses. What I'm going to do is I'm going to bring down the two outside pieces. Don't touch those. And then the inside piece, right, that 5x in the middle, I'm going to rewrite that 5x using 2 and 3. So how can I rewrite 5x using 2 and 3? 2x plus 3x, right? So the inside here is going to become plus 2x plus 3x. And by doing that, we've now created 4 terms on the inside. So we do grouping on that. Would you be so kind to factor a GCF out of those first two? 2x. You're left with x plus 1. We need to match that on the other one. So what needs to be out here? 3 plus 3, right? Since they match and everything worked out, I can write my last line. So I write what they had in common, which was x plus 1, and then in the last parentheses, 2x plus 3, the two things that were in front. Just a quick check, no difference of squares, no sum of cubes, nothing happening in there. That's it, we're ready to box it up. Did that help? Okay. I was asked about 49, right? Did you say 49 or 47? 49? I'll do 49 real quick. 49 was 125 x cubed plus 27y cubed. Do I have a GCF here? No. How many terms? 2. Okay, so checking for sum of squares, difference of squares, sum of cubes, difference of cubes. Sum cubes, okay, sum of cubes. You just need to be able to rewrite this as something cubed plus something cubed. So how about 125? Is that something cubed? It's 5, right? And then the x cubed is just x, right? So 5x. When I cube that, it's 125x cubed. Got that? Over here, to get 27, I need to get a 3 in there, because 3 cubed is 27. To create the y cubed, I put a y. See it? Okay, so in the formula, a cubed plus b cubed, right? It should turn into a plus b times a squared minus ab plus b squared. For us, a is 5x and b is 3y, isn't it? So let's rewrite that formula. Enough room for 2 terms and 3 terms. Okay, a plus b for us is 5x plus 3y. All right, a squared. 25x squared, because you have to square the 5 and the x. All right, that's critical. 25x squared. Does everyone see that happens? If I say come in here and square 5x, you square the 5 and you square the x. Okay, minus a times b. So this times this, 5 times 3 is 15. And then x times y is xy. Plus b squared. So now you have to square the b, which means you square the 3 and the y. So 9y squared. What did I say about if you do this, you'll get 3 terms here every time you do use that formula or the difference of cubes formula, either one. You'll always have a trinomial out here. What did I tell you about that trinomial? What's that? It's always prime. This will not factor, okay? So we do not have to go and say, oh, look at this, 3 terms, let's do AC method. If it came from the formula has a trinomial in it. If that factored, right? If that factored, the formula would not be this. The formula would be broken down further. The formula stops here because that is guaranteed to be prime. That's why it stops. All right. I'd like to collect what you have, please. So just make sure your name is on it and kind of get them up here somehow, some way. Mm-hmm. Mm-hmm. But then I heard on the video we turned something in. I didn't know which one it was. Let me see. You know what? Can I have them both, and I'll figure it out? Okay. What is that? Yeah, that's this one. That's this one. Yeah, just put your name on it, just so I have it. I'll sort through it. And anybody else turning in homework? It's okay if it's not stapled, as long as your name is on the first page. Okay. Last call, last call. All right. Thank you. I don't have one. Just make sure your name's on the first page. Okay, that'll work. Let me see if I have this one ready to go. I'll do it at the end of class. Yeah, because the plan is to have a 1-question quiz at the end. Okay. So there are a few things that we need to just make sure we're clear on. Okay, in this section, I'm going to assign some more homework out of this section because just more practice. All right. But let me show you 2 examples that you may run into as you're doing your homework. 3 examples that just so if you run into them, at least you'll have something in your notes that we did something like it. All right. So the first one I'd like to do is something like, where is it? This. X to the 4th minus 8x squared minus 9. Now, when we look at this, we try and factor it. We see there's no GCF, right? No GCF? How many terms? 3, so we're going to try what? AC method, right? So come out here, I make my little X thingy. I multiply 1 times 9, I get, or 1 times negative 9, I get negative 9. And then in the middle, I get negative 8. Yeah, good. I'm glad you saw that. Just for now, let's follow what the process would have told us, which would have been check for GCF. We don't have it. 3 terms, try this. All right? We'll deal with this in a second, how it's going to work out. Yes? If they're 3 terms, you always do. If it's a 1 out here, then really you don't have to because it's a 1. But so if there's like a 2 out here, you have to do 2 times -9. In this case, you don't have to look at it as this. You could just look at the number by itself. Am I answering your question? Okay. Okay. Now, 9, how many ways can we get 9? 1 and 9, 3 and 3. We're trying to get a -8 out of this. So how can we do that? 1 and -9. Okay, now I told you last class that there's basically 2 ways that we've talked about factoring. There's like a quick way and then there's the grouping way. I said you should be able to do both and know when to use which one. This problem is best done by grouping. All right, so that's the way I'm going to show it to you. Take down the ends of this. So we have x to the 4th, and we have -9, right? Now the middle, I need to create a -8x squared, don't I? I need to create -8x squared using the numbers 1 and -9. So what could I do to create -8x squared from 1 and 9? I could do plus 1 what, though? What are we trying to create? X what? Squared. So I should put a 1x squared and then a -9 what? X squared again. Do you see that in this problem, the middle term is what we're trying to create. The numbers are just used to figure out the coefficients, right? The actual variable, what's there, is dictated by what's up here. In all the problems we did before, that was an x, right? So we just put like 1x minus 9x. But if it's an x squared, we do 1x squared minus 9x squared. You see the difference? Now we still have 4 terms, so what do we do on this? Grouping. Okay, so I'll slash that thing. Make sure you go right after the second term. Right. It would not have mattered if you had done it the other way around. The final answer should look the same. Out of the first 2 terms, what can I factor out as a GCF? X squared. What will be left? X squared plus 1. Questions there? What do I do next? Okay, put an x squared plus 1 over here and try and match it up. So I need to turn my x squared into a -9x squared, so all I need is a -9. Good. A quick check of that. -9 times x squared is -9x squared. -9 times +1 is -9. So since these things match, I can write them down, right? X squared plus 1. And then in the other parentheses, what? X squared minus 9. Now what I'm hoping is going to start happening to you is that at some point you start seeing the difference of squares almost immediately, right? Do you see that? Now what about the x squared plus 1? That's sum of squares and that's prime, right? But the x squared minus 9 is a difference of squares. Because 9 is 3 squared, right? Now I still will do this on the side real quick. X squared minus 9 is x squared minus 3 squared. Using the difference of squares formula, if I have a squared minus b squared, it turns into parentheses a plus b, close parentheses, parentheses a minus b, close parentheses. I'm showing less of that because we've done, I think, enough of them. I'll have 2 sets of parentheses. What will it be? X plus 3, x minus 3. Can I go any further? Nope, that's prime. These aren't difference or sum of cubes or squares or anything like that. I am done. Yes? if they were both plus 3's, then we could put them together as x plus 3 squared and get rid of this. It doesn't matter. If you notice you've got two things that are exactly the same, you can just write one of them squared. But it's not wrong to not do it. Okay, so that's the first type I wanted you to see. The next one is the one like number 13 that I asked you to skip. But if you did it, good. Do we have a GCF? No. Almost, right? But we don't. How many terms? 3. So when we have 3, we try and do this AC method. Goes like this and like this. We should have a negative 15 on top, and on the bottom, 2. So you start considering different ways to get negative 15 and 2 from two numbers. 3 and 5. Which one of them is negative? Because one of them has to be negative. Negative 3. So how about I go 5 and then negative 3? You agree? Now again, this is another problem where grouping is more efficient, I think, in getting us to the answer. If I take the outside terms and write them down, I get a squared. Over here I get minus 15b squared. Now the inside, what I'm trying to get is a what? But I'm trying to get the 2ab, right? I said that the what's up here dictates, these are just the numbers that'll create it, but what the variable up here, or variables in this case, a and b, dictate what this middle piece looks like. So I'm going to have 5 of something minus 3 of something. What is it? 5ab's minus 3ab's. Do you see that? 5ab's, take away 3ab's, you have 2ab's. So that works. Now split it. GCF out of the first two, A, and then you're left with plus 5b. Yes, you can. It'll work that way also. I try and match that up over here, don't I? A plus 5b. What needs to go outside here if I'm going to match it? Negative 3 needs to be out here. And since they match, I'm at my last step here, I think. A plus 5b, A minus 3. Oh, yes, thank you. I'm very glad you pointed that out. We missed it. I missed it. Right here, we're trying to turn A into what? Negative 3ab. So we don't have a b here, right? We need a b. This needs to be negative 3b. Thank you, sir. Glad you caught that. That would have been trouble. 3b. Everyone see that? B that needs to be there? Check it here. It goes and it gets you that. And then negative 3b times positive 5b. You get the negative 15, and then you get b and b is b squared. So how does that change things? My a plus 5b is out here, but then I have a minus 3b. Neither one of those will factor further, so I can say I'm done. All right, I'd like to go and show you the last type problem out of this section, and then we're going to start the next section. Oh, sorry, it's going to be loud. What if you've got something like this? Y squared times 2x plus 1 minus 2x plus 1. Now, the instructions here are to factor. Everything we've been doing up to this point has been factor, factor, factor. Yeah, good. This is actually very close to this last step of grouping, isn't it? Remember in the last step of grouping, we were trying to have something and something match up so we could factor it out? This problem, the way it's presented in the very beginning, you don't have to go through all this crap to get to it, okay? What they're trying to get you to see in a problem like this is if you're just sitting there and it's staring at you, right at you, are you going to miss it or not? You know, you don't want to overcomplicate this problem. You have your common factor here already. So just pull that out in front like we have been doing. 2x plus 1. And then what would be left? The two things in front, right? Now be careful on the two things in front. It'll be a y squared, then what? Minus 1. Box it up. No, yes. You have a difference of squares right there. Two terms, right? One of them is squared, the other one is 1. So anytime you have something squared and the number 1 and subtraction between them, that should be able to be broken down, right? That's y squared minus 1 squared. I'm doing that on the side. So y plus 1, y minus 1. So it splits into two things here, y plus 1, y minus 1. Now we can say we're done. Let's look at like the most common difference of squares that you see. I mean, like x squared minus 1, x squared minus 4, x squared minus 9, x squared minus 16, x squared minus 25, x squared minus 36, right? X squared minus 49, x squared, I'm getting sick up here, minus 64, x squared minus 81, x squared minus 100. That's about as far as we'll go. Okay? What would this be factored? X plus 1 times x minus 1, right? This one, plus 2 minus 2. X plus 3, x minus 3. X plus 4, x minus 4. X plus 5, x minus 5. X plus 6, x minus 6. Right? All those in parentheses. Keep going. Those are the ones we want to get to the point where we kind of recognize them, right? We see them, that's a difference of squares. The ones for cubes are things like this. X cubed plus 1, x cubed plus 8, x cubed plus 27, x cubed plus 64. And I could keep going, but especially like these first three, those are ones you should just be like thinking, oh, okay, wait, that's going to go to a formula, right? Now the formula is a lot harder for these than it is for those, but so when you see this one, y squared minus 1, that should be kind of like x squared minus 1. All right. I think we are going to call it the end of this section. Let me give you what your homework is going to be. There it is. So we're going to do, or you're going to do, numbers 51 through 89, which is a lot of problems, but do it's supposed to say every other odd. That means start at 51, skip 53, do 55, skip 57, do 59, skip 61, right, do 63. Just do that, every other odd. But if you're really trying to get good at this factoring, you just go do every odd. And I know it feels kind of like torture, me putting you, making you do all this homework, and it's repetitive, but it's like anything else. You've got to practice it. You got to work out all the little kinks, get all the little, I keep making mistakes with this sign. I keep forgetting. That only gets better after time and practice. So please do these. I'm not going to collect this for 2 quiz grades, all right? But you need to do it. It's going to be 4 quiz grades. No, it's for your own good. All right, we're going to start a new section today. This will be the last section that will be on the test, which is a week today. So we will review. We won't finish the section today, but we'll finish it on Thursday and we'll review on Thursday. So be here Thursday, please. 6.6. You thought so, huh? April Fool's not happening. Did y'all see that? My wife posted something on Facebook about an April Fool's prank that. Yeah, did you see that? That's pretty funny, right? Just go look it up. I'm not going to give it away, but just go look April Fool's on College Professor, and yeah. Zero factor property. All right, we are going to discuss what is called the zero factor property. This is an extremely important property in mathematics, okay, in all mathematics, not just this class, moving along throughout any math class you take in the future. This property is used everywhere, all right? Here's what it says. It's a pretty unassuming idea. Let me write it down first. Let's see if we can get our head around what it's saying. Here's what it says. If A times B, so that dot means multiplication, equals 0, then A equals 0 or B equals 0. That is the zero factor property right there. That's it. All it says is that if 2 things multiply to be 0, then either the A was 0 to start or the B was 0. Another way you could look at this is to say the only way you can get 0 when you multiply 2 things is if one of them is 0. So let's just see how this property works and why it works this way. Let me pick two things. What if I tell you, for an example here, that 5 times something equals 0, right? Is there anything else that I could use to get 0 other than 0 itself here? There's nothing else that will work, okay? The only number that I can multiply times 5 to get 0 is 0. So that forces me to have to make that 0, doesn't it? All this is saying, the zero factor property is saying, if you have 2 things that multiply to be 0, right? One of them may not be, but one of them has to be, right? That's why we say here, if 2 things multiply to be 0, that first one has to be 0 or the second one has to be 0. What if they're both 0? Well, then they're both 0. Who cares? Still 0, right? So we're guaranteed one of them must be 0. Now, this zero factor property extends if you have more than 2 things, right? If I say A times B times C equals 0, so if I say if, that's true. So if 3 things multiply to be 0, what do you think we can say? One of those 3 things has to be 0. A has to be 0. B has to be, I should say or B has to be 0, or C has to be equal to 0. Bless you. Gonna hurt yourself. Were you sitting over there doing the same thing the other day? No? I thought I made a big deal about someone sneezing like that the other day. No? I did? Like, yeah, she was over there, right? That's it. All right? Just a little pressure release. Okay, so that's it. Now, here's where people make mistakes with this. Think about this and tell me if you think this is true. If A times B, I'm writing in red for a reason here, equals, let's say, 2, then does that mean A has to be 2 or B has to be 2? No? Yeah? Is it possible that A or B could be 2? It's possible, right? Like if I said A was 2 and B was 1, it would work, wouldn't it? But the zero factor property guarantees us that one of these has to be, right? So does zero factor property work here? So can anybody give me an example of two numbers that multiply to be 2 where neither one of them is 2? It's not a trick question. There you go. What if A is 1/2 and what if B is 4? What do they multiply to be? Well, what's half of 4? 2. Are either one of these 2? No, 4 is 4. Half is half. They're neither 1 or 2. So it appears that if two numbers multiply to be 2, that does not mean that one of them had to be 2. Look at what this property is called. What is it called? The zero factor property. Why do you think it's so important that they say 0? Because it only works for 0, okay? Does not work for 2 or 5 or 10 or any number other than 0. If it's 0, though, this has to be true. I've seen that mistake. I even saw it in from a Cal 3 student the other day. The zero factor property. This right here is just to show you not to take this property past what it is telling you can do. Only getting a 0 over here allows you to use this, all right? Hey, either wake up or leave, one or the other. Yes? Okay. Well, yeah, I mean, if there's a way you can delete that from your memory, you can. But I just want to show you not to do this. I hate showing mistakes, but it illustrates the fact that you cannot extend this property out to any number you want. All right? Now, how are we going to use this? How is this zero factor property going to come into play? Well, let's go back to something we've seen before that's kind of, I guess, hopefully, a relatively easy problem. Let's see. What if I tell you that 4 times x equals 0? What does x have to be? 0, right? Now, there's two ways to do this. One way is to do what we did in the past, which would be try and solve this equation, getting x by itself. How do I remove the 4? Divide both sides by 4, right? And then the 4's on the left cancel. We get x equals, what's 0 divided by 4? 0. And there you get the answer that x must be 0. That's one way to do it, right? Another way to do it is to use what we just learned, the zero factor property. Isn't this saying that something times something must equal 0? So it's kind of like the A times the B must equal 0. So from that, can't I write down two things? 4 must be equal to 0, or x must be equal to 0. Do y'all see how that's the zero factor property? Well, what can you tell me about this? 4 is not 0. Okay, so that can't happen, which makes x have to be equal to 0. That's using the zero factor property. So that's just the beginning of where we're headed. Now let's try something else. Look at this here. I want us to solve this equation. 4x squared equals 16x. Yeah, let's just do that. Notice the instructions for this problem. They say to do what? Solve. We're not asked to factor. We're not asked to do anything that we've been doing for the last couple of days, right, in this class. I'm asked to solve an equation. We have an equal sign here. We haven't had an equal sign in a long time, right? Our answers should be things like x equals 2, x equals 5, x equals -4. It should be an answer, right, a number. So how can we do this? Well, right now, you could look at it and try and figure out, right? You could try, but that turns out to be pretty inefficient because it's very easy for me to give you a problem that there's just nobody in here who's going to be able to look at it and get it, all right? So we have to have a method, a process. Let's use the zero factor property. The way we do that is we first have to get a zero, right? So because it's an equation, we can always take things from one side, move it to the other, right? I'm going to choose to take the right side, move that 16x out of there, and leave nothing there, which would be a 0. So how can I remove 16x from the right side of this equation? Subtract it, right? Subtract it. So I'm going to subtract 16x here. Whatever I do to the left side, I must do the right side, right? Now, what happens on the right-hand side of this equation? The right-hand side. It all cancels and you're left with 0, right? You're left with nothing. 16x, take away 16x is nothing. So there's your 0 for zero factor property. How about 14x squared minus 16x? Are you allowed to subtract those in any way to come up with something? They are not like terms, are they? Remember, like terms meant you had to have the same variable raised to the same powers. These are not like terms. So what we have there is exactly what we started with, 4x squared, and we tried to take away 16x, didn't we? So I just wrote them side by side like this. Do you all agree with that? Right now, can we apply the zero factor property? Well, do we have something times something? We have something minus something, right? We don't have something times something. How do we turn subtraction into products? How do we turn pluses and minuses into things being multiplied? How do we turn things that have pluses and minuses into things being multiplied? How do we turn pluses and minuses into things that get multiplied? We factor them, don't we? That's the whole reason we factored them. Well, yeah, there was a reason why we did everything we did. The goal was that we would be able to solve an equation with it. And so what we do now is we look at this, we don't forget the equal 0 here is there, but let's just act like now I'm asking you to just factor that side. So we have GCF there, 4x, right? What's left? X minus what? 4, close parentheses, and then bring your equal 0 in there. You see that? Now, do we have two things being multiplied? Yes, I'm going to exaggerate that multiplication symbol. There it is, right? I have something times something equals what? 0. I can apply the zero factor property because I know I can call this whole thing here A, this whole thing here B, and so it looks like A times B equals 0, doesn't it? A times B equals 0. The zero factor property tells me if A times B equals 0, then what? One of those has to be 0, right? So what I know now from this, and I like to, well, I'll do it kind of to the side here. Because of this, what I can say is that, what two things? Either 4x has to be what? 0 or x minus 4. The whole thing in here has to be 0. One of those has to be true, right? Now, what about 4x equals 0? Didn't we do that on the problem just right above this? And we said that x was 0 there, right? So this just brings us to the conclusion that x must be 0. And now on this one, how can I get x by itself here? Add 4 to both sides. So x is 4. I have two potential solutions to the original equation. And now if well, actually there's the original equation right there, right? Let's just check. Let x be 0. What do you get over here? If x is 0. You get 0. What do you get on the right side if x is 0? Does 0 equal 0? Yes, so that does work. How about 4? Well, what's 4 squared? 16 times 4 is 64, right? Now, 16 times 4 is 64, so 64 equals 64. Those are the two ways to make that statement true. So we start with an equation. We move everything to one side to get it to equal 0. We factor that side. We set each of the factors equal to 0, and we solve each of those small miniature equations. Those are the solutions to the original problem. Do you see how that zero factor property works? That's right. Yep. I don't plan to give you any homework on this, but I do want to show you one thing. I was talking to my other class about the homework that you had that was turned in today, and just about how math is, like how it builds on itself, right? And how it gets, you have to get to a point, you will get to a point where factoring will be something that you're like, man, I wish I was factoring again. Like, that was the good old days when all I had to do was factor, you know? Because the math you'll be doing will be requiring so much more. It's like relative pain, you know? Have you ever, like, accidentally stubbed your toe on a couch, you know? Well, have you ever, like, had your leg broken in 4 different places by something? I mean, the stubbing of the toe becomes nothing when you compare it to something like that, you know? So that's what I'm saying. Like, the pain in math later makes this stuff look relatively painless. But you have to get to that point, and you have to keep working. So let me show you, since we're almost out of time, I'm going to show you the solving of an equation using what we just did, zero factor property, done in, where was it? This is a calculus class. Oh, it was this one right here. Okay, now this problem in this calculus class is to take a surface, which could be the Earth or anything, take some point, okay, in space somewhere, and forget this is up here for now. Just say this is like a mountaintop or something, and this is maybe an airplane, who knows. And then find the point on this surface or on this mountain that is closest to that point. So where is that point and how far is that distance? And all you know is the surface. So to do that, it requires the math that you see here, okay? Now I want you to focus all your attention on one little piece of this problem. The one that has the 3 on it right here, okay? This says 2z equals lambda. Lambda is like a variable, okay? It's like x, y, z, m, t, l. 2z equals lambda 2z, all right? So first thing that happened here is that we divided both sides by 2 to get rid of the 2, okay? Y'all see that? 2's are gone, which gives me this. Now, I'm going to try and use the zero factor property. So I take the lambda z and I move it to the other side. by subtracting it on both sides. So see it appear on the other side, now I have a 0. Then look at these two. What do they both have in common? A z. I pull a GCF out. This is what's left, right? Zero factor property tells me that if two things multiply to be 0, I can set each one of them equal to 0. Now, when you set 1 minus lambda to 0, you get this when you solve it. Make sense? Okay, so that is what we're learning to do today. But you can see how that's implemented later on in math. It's just a subtlety within a problem. Yeah? Okay, you have your homework assignment. I don't have enough time for a quiz. You got lucky, but I need attendance, so we'll have to do that. As far as I know, no.